My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 232. In this lecture, we will try to understand dimensionality reduction and visualization with respect to principal component analysis. I can say PCA for dimensionality reduction and visualization. Imagine if my data set capital X, let me say my capital X is data set is of two-dimensional data set. How many dimensions? Let me assume this particular data set has two dimensions. It's a two-dimensional data set, and let's assume I have n points. Let me write this one like this. Let me say my capital X equal to 1, 2, 3, so on. There are n points and how many features? Let me assume there are two features, isn't it? Let me assume this is how my data set looks like. This is, let me say like this, this is my feature 1 and this is my feature 2. I compute the eigenvalues and eigenvectors of capital S. What is my capital S? That is covariance matrix. How can I calculate covariance matrix? I already discussed in our previous lectures. How can I do it? It is simple formula X transpose X, isn't it? Now let me say as it has two dimensions, I will get two eigenvalues lambda 1 and lambda 2. Lambda 1 is greater than or equal to lambda 2. Your V1 is eigenvector corresponding to lambda 1 and your V2 is eigenvector corresponding to lambda 2. I can say Vn is my top eigenvector corresponding to lambda 1 and V2 is my second top eigenvector corresponding to my second eigenvalue, which is lambda 2. Now question is, so this is two-dimensional data set. Now let's say I want to convert, it is 2D, I want to convert this two-dimensional data set into one-dimensional data set. How do I do it? It is very simple. Let me say, let me rewrite it again. Let me say my capital X. My capital X equal to, as I told you, how many rows? 1, 2, 3, so on. There are n rows, n data points with how many features? With two features. F1, F2 are my features. Yes, this is my, let me say, this is some ith point. I can say this one is Xi transpose. We know what is this Xi transpose. Basically, this is my Xi transpose. Let us assume this is point. Let me say this. This is my point Xi. Just let me say like this. This is my point Xi, isn't it? Let me assume some point. Some point is here. It's some point Xi, isn't it? Let me assume this is my point is Xi. How do I convert into 1D? My problem is we have to convert into 1D. I know that instead of projecting this data into F1, this is feature 1, the best direction to project is V1, isn't it? Why? Because this is the direction along which you can find maximum variance. Because that explains, I will repeat, I know that instead of projecting this data onto F1, this Xi onto F1, instead of projecting this Xi onto F1, the best direction to project Xi is V1, isn't it? Because that explains most of the variance, thereby retaining most of the information. I already discussed this concept in my previous lectures. So what do? I basically create a new data set X dash, capital X dash, which is only one dimensional, and that dimension is V1. Yes, let me say I will convert into a new data set. Let me convert this capital X into capital X dash. What is the dimension? Which is of only one dimensional vector, and that's the one dimensional, and that's dimension is V1. I have n points here. My ith point is basically xi dash. Let me say my ith point is xi dash, isn't it? This is only one dimensional. How will I get xi dash? Let me say like this: 1, 2, 3, so on. There are n points. What is the dimension? I am keeping this. This is, let me say, ith. This is xi dash. Xi dash with only one feature, with only one column. My xi dash is nothing but, I can write xi dash is equal to xi transpose into V1. What is this V1? Top eigenvector. I am projecting xi on V1. How can I project? We know how to project. We already discussed projection in our previous classes. So basically I am projecting xi onto V1, along which you can have maximal information or maximum variance. What does it mean geometrically? I am taking my point xi. I am taking this point xi. I am projecting it onto V1. I am projecting this xi onto V1, isn't it? That's what it says. I am saying this is the best representation on this axis. Why am I projecting onto V1? It is a top eigenvector. I am saying this is the best representation on this axis V1. My feature, I have changed to V1 from F1, isn't it? I have changed to V1. Just see, this I already discussed in my previous classes. We rotated these axes. How can I rotate this axis? This F1 is rotated with the F1 dash, isn't it? It is F2 is rotated into F2 dash, isn't it? I can say, since V1 is one dimension in which the variance is maximal. This V1 is one dimension along which variance is maximal. Why? Because your V1 is U1. V1 is maximum eigenvector. I can say it's an eigenvector corresponding to maximum eigenvalue. If I have to convert this data from 2D to 1D, our intention is we have to convert data from 2D to 1D. One way to do it is by projecting my data onto V1. That's what I am doing. As I told you, why am I projecting on V1? Why? Because it is a eigenvector corresponding to maximum eigenvalue along which you can have maximum information or maximum variance. So in this type of dimensional reduction, what am I doing? I am doing maximum variance method. This maximum variance method I already discussed. Which method I am using? Maximum. There are two approaches. Maximum variance method. I am using this maximum variance method. I am doing maximum variance method, or which is also called PCA. I can say my two-dimensional data. I have originally two-dimensional data. I am converting this into one-dimensional data by using maximum variance method. maximum variance method, I can say that is, or I can say PCA, isn't it? Yes. In PCA, when I want to reduce data from 2D to 1D, this is how I will do it. There is other very interesting idea. Of course, if you have 10 dimensional data, let me assume I have 10 dimensional data. Let me say like this. Let me say if I have 10 dimensional data, let's assume I have capital X. I have capital X with how many dimensions? With 10 dimensions. 10 dimensions, isn't it? What are those dimensions or features? Let me say F1, F2, so on. Let me say there are 10 features, F10, and let's assume I have n points, 1, 2, 3, so on. Let me say there are n points, isn't it? Yes. And my xi is here. How can I write my capital X? My capital X is, how can I write? 1, 2, 3, so on. I can say n. This is F1, this is F2, this is F3, so on. I can say it is F10, isn't it? Let me say this one is xi whole transpose, isn't it? This is what is the order? This is n by 10. How many rows are there? There are n rows and 10 columns. Now I want to visualize this data. What is my intention? I want to visualize this data, but it's difficult to visualize as it has got 10 dimensions. Now I want to visualize this data. That's the, let's say I want to visualize this data. What does it mean? It means I want to convert this data, this capital X. I must convert this capital X into X dash, which is of 2 dimensions. Why? Because if it is 2-dimensional data, I can visualize it easily. Because it is very easy to visualize, I have to convert this n by 10 into X dash. What is this? What is this dimension of this X dash? It must be n by 2. That is our intention, so that you can visualize it without any difficulty. How can I do it? It is simple. I must calculate covariance matrix. How can I calculate? X transpose X, that is X transpose X. Compute eigenvalues. How can I compute? How many eigenvalues will I get? I will get 10 eigenvalues. Why? Because your S is 10. This is X transpose X means what? What is X transpose X? X means what? N cross 10. This must be 10 cross n. What is X? N cross 10. Therefore, what is the order of this S? S order will be 10 by 10. Therefore, how many eigenvalues can I get this for covariance matrix? Eigenvalues. Let me assume eigenvalues of capital S are lambda 1 is, let me say like this, greater than or equal to, lambda 2 is greater than or equal to, lambda 3 is greater than or equal to, let me say lambda 10. Correspondingly, let me say I have eigenvalue vectors. V1 is an eigenvector corresponding to top eigenvalue. Next top eigenvalue is lambda 2, whose corresponding eigenvector is V2, and V3 is eigenvector corresponding to lambda 3, and your V10 is 10th eigenvector corresponding to 10th eigenvalue. For each of them, I will get for each eigenvalue, I will get my eigenvectors, isn't it? I know that V1, I know that V1 and V2. I know that, this is important, I know that V1 and V2 are the best dimensions, are the best dimensions, are the best V1 and V2 are the best dimensions which will preserve, which will preserve the most of the information, which will preserve the most of the information, isn't it? Which will preserve most of the information. So what I will do here is I will make my features after dimensionality reduction using PCA. I will create a new data matrix capital X dash. I will create my new data matrix capital X dash such that for each point xi, let's assume I have xi dash. Let me say xi dash. How do I compute my xi dash? That's important, isn't it? Xi dash is nothing but it has two values. This xi dash must have how many values? Two values, isn't it? It must have two values. The values corresponding to, these values corresponding to V1 and V2. Values corresponding to V1 and V2. What do I do? How can I get my xi dash? My xi dash is essentially xi whole transpose into V1 and xi whole transpose into V2. I can say, as I am converting into two-dimensional, I can say this is my first feature. This is my first feature and this is my second feature, isn't it? In that case, it will be converted into two-dimensional. Literally taking my data and multiplying. This is my data. Xi transpose is my data, isn't it? Taking this data, my original data, xi transpose, literally taking my data and multiplying with top two eigenvalues. V1 is top eigenvalue and V2 is next top eigenvalue. I am multiplying these two top eigenvalues with the original data so as to get my top two features. These are known as, these two features are top two features. That's important. I am converting top two features. I am converting a 10-dimensional space into two-dimensional space so that 10D data, what is original dimension? Original dimension is 10D. So this 10-dimensional data which I can't visualize, I cannot visualize this one. I can't visualize this one. As I can't visualize, I am converting this into two-dimensional data. Just we converted it into two-dimensional data. This is my 2D data. Xi whole transpose into V1, comma xi whole transpose into V2. Isn't it? Who is doing this one? With the you are reducing dimension. We are reducing dimension by using PCA, principal component analysis, with eigenvalues and eigenvectors. I can visualize, this is my 2D, I can visualize which is something better. We will see this example, MNIST database example. In MNIST, in the case of, let me say like this, in the case of MNIST database, we already discussed about MNIST. What is the size of MNIST? Which has got 784 dimensions. This 784 dimensions data, I can convert this 784 dimensional data into two-dimensional data by using this PCA. We will convert this 784 dimensions into two dimensions using PCA, and we should visualize it in the next lecture. We will try to understand. For now, this is how we do it. We take top two eigenvectors because we want to do two-dimensional visualization. Now imagine if I want to visualize 100-dimensional data. Suppose if I have, let me say, let me assume my capital X is of 100 dimensions. It is of how many dimensions? 100 dimensions. 100 dimensions, isn't it? 100 dimensional data set. Therefore, what are the features? Let me assume F1 is my first feature, F2 is my second feature, F3 is third feature. Let me say this is F100, 100th feature. Sometimes in machine learning, what happens? In machine learning, what happens? We might want to use PCA to convert this 100 dimensional data into, let me say, I am interested in converting 50 dimensional data. It is not for visualization. It is not for visualization. We usually convert into 2D or 3D. But to make use, to apply some machine learning algorithm, I have to convert this 100. Let me assume there is 100 dimensional data. If you want to convert into 50 dimensions, isn't it? So what I do here, remember, this is not for visualization. This is to apply some machine learning algorithm. I can say it is some sort of pre-processing technique. In that case, what I have to do? So what do I do here? I basically pick top 50 eigenvectors. Top 50 eigenvectors, isn't it? So since the dimensionality is 100, since the dimensionality is 100, I can say this, when I compute capital X, what is the procedure? Same procedure. What I have to do? I have to calculate X transpose X. I will get, what is this matrix order? This matrix order is, it is 100, its order is D by D order. D equal to what? D equal to 100. Therefore, you will get by 100 by 100. Therefore, how many eigenvalues you will get? You will get 100 eigenvalues. Lambda 1 is greater than or equal to lambda 2, is greater than or equal to lambda 3, is greater than or equal to so on, is greater than or equal to lambda 100. You have 100 eigenvalues. Therefore, since this is 100 by your matrix, which matrix? Your original matrix is of 100 by 100. Therefore, what I have to do? I have to top 100 eigenvalues. Correspondingly, I can have 100 eigenvectors. This is V1, this is V2, this is V3, this is V3, so on. You can have 100 eigenvectors. I will take top 50 eigenvectors. Means which top 50 eigenvectors I will take? V1, V2, so on, V50. These are top 50 eigenvectors, and I simply do projections. Simply do projections, isn't it? Give any point xi whole transpose. This is my original data. If I want to transform, what I have to do? Xi whole transpose must be multiplied with Vj, so that, for example, I must multiply with corresponding eigenvectors, so that this dot product, I must multiply this data with V1 with V2, just like for 2 dimensions. What I did for 2 dimensions, just recall in previous slide what I did. Just see this one. Where is this? Yes. What we were doing in 2 dimensions, same thing here also I am doing. Where I wrote, I think I wrote somewhere. Yes, no issue. Just like 2 dimensions, here also what you have to do, just you must multiply this original data with the top. What I did for 2 dimensions, I will write for 2-dimensional case. This is 2-dimensional case. What is 2-dimensional case? Xi. If you want to convert into 2 dimensionals, what we did? What I did? Xi whole transpose into V1, comma, Xi whole transpose into V2. This is 2-dimensional, isn't it? If you want to convert into 50-dimensional, what you have to do? Your Xi dash will be Xi transpose into V1, comma, Xi transpose into V2, so on Xi transpose into V50, isn't it? Therefore, that 100 dimensional data will be converted into 50 dimensional data. As I told you, this I am not converting this 100 dimensional data into 50 dimensional data for visualization. This may be something like if you want to apply some machine learning algorithm, just if you want to reduce 100 dimensions to 50 dimensions, then you can apply this procedure. For visualization, you must understand this one. For visualization, what you have to do? For visualization, mostly we use 2D data. Mostly we will convert into 2D. So you can just take top 2 eigenvectors and they should be good enough for your visualization. In the next lecture, we will see how to convert your MNIST data set of size 784 into 2-dimensional data set. Just go through this lecture. This is simple and straightforward. If you have any difficulty, please keep a comment. Thank you very much.